Hello, everyone, and welcome to another episode of Fun with Gen AI. Today, we are going to discuss RAGs. That is a term you may have heard in relation with Gen AI, and what it means is retrieval augmented generation. Now, what does that mean? Well, let's go back. In order to describe RAG, we'll go one step behind, and we're going to discuss a little bit about LLMs, large language models. Well, LLMs are trained on really huge amounts of data, but the data is quite generic, and that data usually doesn't have any information about where the data came from. And the information where the data came from is also called grounding. So make sure that the response that LLM gives is grounded, or means that it has a substantial information about where the data came from. Well, RAG is a solution to this, or one of the solutions to this. And today I'm going to talk about RAG of text. So textual documents and LLMs that process text. RAGs can come also in other flavors, but this is the simplest flavor just to see what is it all about. So what is the idea? Well, the idea is the user comes and makes a prompt. User asks something. Now, for example, you in your company have a company policy, and you want the user to ask something about your company policy and not just a policy that was somewhere on the internet. And for that, you will use rugs. So, what is going to happen? How does it work technically? What happens is that the documentation that you provide, the document, for example, policy document, gets chunked. And what does that mean? It means that it gets split into smaller pieces. Uh, what does that mean? Well, you can see it like this. There are different chunking methods, but you can see it like that. For example, one chunking method that each sentence in your original document becomes a chunk. Uh, in my code today, I will use a different approach, but yeah, there are many approaches to chunking. But the idea is that because the whole document is big, you want to split into small pieces. Yeah. Then what happens is that from these chunks we generate embeddings. What are the embeddings? Well, the embeddings are just encodings of these chunks. You can see it like that. This it's a way to encode a chunk. Yeah. So one chunk gets one number, or actually, usually it's at least 384 numbers. Another chunk gets another number, or series numbers, and these are embeddings. Now, these embeddings are stored into vector database. There are many vector databases. I will show you one vector database today, and they sit there. Now, when the user then asks your LLM about something, before the user's prompt goes to LLM, what happens is that the prompt goes into the vector database. And then the vector database finds the chunks that are the most similar, in certain sense, to what the user asked for. The vector database can return one or more of these embeddings, or actually chunks, and let's say 10 of the most similar chunks to what the user asked for are then combined with the prompt as a context, and then prompt and context go into the large language module, which brings the result. Now, the trick here, or there is a lot of tricks here, but one of the tricks is that this context Actually, you can say, well, on page 17, line 7, you can find this chunk. Or on page 25, line 1, you can find another chunk. So each of these chunks can be uh, referenced, can be grounded. So these chunks can also come from internet, from all other places, but you can ground them. You can say this chunk came from here, and then you can instruct your LLM to say, yes, my result is this because I found some similar thing in chunk from page 21 or from the internet page X. So this is the basic of rugs, and I'm now showing you how to use these rugs in by using the Azure AI services. So let's go a little bit about what we are going to do actually. Okay, so in Azure, I'm going to use. Let's go back a little bit to our image and tell these components what these components are. Our vector database base will actually be Azure AI Search. The embeddings we're going to do through an embedding model present in Azure OpenAI. We're going to do chunking through some normal Python code, and our LLM will be one of the Azure OpenAI large language models. So we are going to do chunking through a code because that is quite generic and not so hard to do, and prompt. And we are also going to make an application that receives user prompt and combines it with the context get from Azure AI Search from embedding model, and then it will feed it to a large language model from Azure, and it will bring result to the user. Now, let me show you where these things can be found in Azure. So, the search, you can find it in the search service. Yeah, I made here a test search service. What you will need from the search service is the URL. You can find it here. And also, you will need keys. And keys can be found here. Yeah, so you will need the URL, the keys for the search service. That is one thing. Let's go back now to the Azure AI Foundry. And then you will need embedding model. This text embedding tree is one of the embedding models. You can find the other embedding models inside of Azure OpenAI. You can search for them, and then you will get the Azure embedding models, and they are used more or less in a similar way as just normal models, but a little bit different. I mean, the setup is very similar. You need an endpoint, you need an deployment API, everything of that. But the ways to use this model is that you say, okay, now I have some phrases, some chunks, and I say, okay, I want to create embeddings, and then this model will return embeddings, or actually these are the list of numbers. So this is our setup. Well, let's now go into our Python application where I will show you how all these components come together. So this is our reg application. So it's like a chatbot. Now at this moment I did not implement the web component. It's a chatbot that works in the command line, but that's up to the point. And then in here you will see in the source several files that each does something. For example, chunk text for X, chunk the text for X. Embedder does embedding of the text. Indexer does indexing of the text, which means it puts the text into the vector database. Retriever gets the text from the vector database, and our application just combines all these things together to make a complete system. Now, actually, when you work with Rex, there are two different, let's say, streams that are working together. One stream is chunking embedding. Yeah, so you have some input data that you want to chunk and embed, and that is separate from the other stream where the user comes and wants to get some information out of the system. Now, in this application, I combine these two things together, but you can just quite easily separate them, or like with this architecture here, very split architecture, good separation of concerns. You can just do whatever you like. Okay, so how does this work? Well, now let us go into the interactive mode, but before the interactive mode, there is also another mode which receives a file, then it chunks this file, then puts this file, actually puts the chunk on a local hard disk in the format of a JSON. Then it checks if one of these chunks is in Azure AI search. So you can say, okay, my chunk has an ID. I check if it is in Azure AI search, and if you make the ID based on your SHR encoding of a chunk, it's reasonably unique. So you just check, okay, is this do you have the chunk with this ID? And you do it for all the chunks, and then you can see if you need to put any of these chunks in your vector database. If you need to put some of the chunks in your vector database, then you just call the embedding function and get the embeddings of these chunks, and then put those embeddings plus the chunks into a vector database. One particular thing for Azure AI Search, which is used here as a vector database, is that it needs schema to work. So the schema is here. Yeah. So this schema is put into an Azure search service, and then the schema has a name. So it's called myRegIndex. So this is it's also called the vector database is also called the indexer. Yeah. And then it has some fields, which means that whatever we put in the vector database, we need to have these fields: the ID, the content, some metadata. ID is the ID. We are going to use encoding or coding of the chunk, unique coding of the chunk. Then there is content, which is chunk, which is just a piece of text. It's a string. And then there is metadata, which actually will be the embedding vector, the vector of numbers that represent this chunk. And you will see that in this schema, we also will use vector search. We'll use vector search called HNSV with certain parameters. And this vector data will be searched by using this vector search profile. And actually, you see dimensions 1536. So the embedder that we are using will give us a vector of 1536 numbers that we're going to be used in this search. Okay. Now in the RegApp, so what we do, we embed the question. Yeah. So the user asks something, we make an embedding out of this. Then we search for similar chunks. As we said, so the user asks for something, and for example, in the company post, you want to find what the user asked for, and the embedding actually gives you that. So we search, we say, okay, we search by using this question, and we find 10 chunks that are similar. Now, In this case, if you don't find any relevant information, then we just say bye. It can be done differently, of course, but this is a simple way. Then we say, okay, we build the prompt from retrieve chunks and the question, and then we just ask Azure OpenAI to give us the result. And that is, and then we continue until the user says, okay, I want to exit. So yeah, let's see how that works. So I will now go into the terminal. I will run this system. Okay, the question is now my documentation is about underwriting. So I have the document about underwriting. So tell me some about writing. Yes. Okay. And then I get something about underwriting. But if I say give me something about football, yes, I don't have enough information to answer this question. And that's more or less it. You can check inside of the embedder what the embedder does. So embedder embeds the text into the model. The chunker chunks the text. These are actually components are all rather complex. They're not really simple, but they're not that complex. Also, this is the indexer. It's the retriever. Yeah. So yeah, please use the documentation provided, the GitHub repository, and play with Drags in Azure. Thank you all, and see you all next time.